Now that you know how to set up absolute value inequalities, now let's actually go through the solving process. So notice that this notes template is the same as the last videos, but I have included what we did in the last video on here. So we've already talked about what 3x plus 6 absolute value greater than or equal to 12 means. We talked about how it means the expression 3x plus 6 is a distance more than or equal to 12 units from the number 0 on the number line. So here's my number 0. I go out 12 units, and that means that 3x plus 6 has to be somewhere out here. Or I go back 12 units, and if 3x plus 6 is somewhere out here, it's also a distance of more than 12 units. So let's go ahead and set that up and solve it. So we can say that 3x plus 6, if it's down here, is less than, and since it's a closed circle, or equal to negative 12, or if it's out here, 3x plus 6 is greater than, again, because it's got the closed circle, so or equal to positive 12. If I solve each of these, I start by subtracting 6, and I get over here 3x is less than or equal to negative 18. I divide by a positive 3, so I do not flip the sign. They cancel, and I get x is less than or equal to negative 6. I'm going to drop my or down. Solving this one, I start by subtracting 6, and I'm left with 3x is greater than or equal to 6. I divide by 3. I get x is greater than or equal to 2. So x is less than or equal to negative 6, or x is greater than or equal to 2. So here's my solution. And then it says, and graph the answer. So this up here was not the graph to my answer. That was the graph just to help lead me in the correct direction to getting my answer. So I'm going to have a negative 6 on here and a 2. 0 is maybe somewhere here. So the first part, x is less than or equal to negative 6. So I put a closed circle at negative 6, and I shade everything less than negative 6. Or x is greater than or equal to 2, or I can put a closed circle at 2 and shade everything bigger than 2. So if I pick any number from this region or any number from this region, it will make that a true statement. The second example that we looked at together, what does absolute value of 2x plus 6 less than or equal to 8, what does that mean? Well, it means that the expression 2x plus 6 is a distance less than or equal to 8 from 0 on the number line. We talked about that. So notice that I have the graph, notice that I have the graph set up here already that we did on the last video. So I have to be a distance of either between 0 and 8 or between 0 and negative 8 in order to be in between, or excuse me, in order to be a distance of less than 8 from 0. Sorry about that. So 2x plus 6 can be anything in here. So how does that look in terms of an inequality? Well, we talked about how we could either set up 2, but I'm just going to set up 1 and say that 2x plus 6 has to be less than or equal to 8, and it has to be greater than or equal to negative 8. It has to be right in between those. So solving this compound inequality, I subtract 6 from each side. Remember, my sides are created by my inequalities. I get negative 14 less than or equal to 2x less than or equal to 2. I divide by 2. I don't have to flip anything because it's positive. And I get negative 7 is less than or equal to x is less than or equal to 1. Again, this was not the graph to my answer. That was the graph to help me to set up my new inequality so that I could solve that question there. So here's my answer. Here's my solution set. If I wanted to graph that, it looks like x, remember this is an and statement, so x has to be between negative 7 and 1. So here's negative 7, here's 1, 0 is probably about here. It looks like I'm going to use a closed circle for each of them, and I'm going to shade everything in the middle. We also looked at this one. So we talked about how you first had to get the radical by itself, You first had to get the absolute value equation by itself. So we got the bars by itself by adding 5 and then dividing by 3. So this is what we got in our last video. We then said that that meant that that expression 2x minus 4 had to be a distance of more than 4 units from 0. So 2x minus 4 could either be somewhere out here and be a distance of more than 4, or it could be somewhere out here and be a distance of more than 4. So if I want to solve that, what am I saying? Well, I'm saying that either 2x minus 4 is either less than negative 4 or 2x minus 4 is greater than positive 4. Notice that, I'm going to scroll up a little bit here. If my original equation was or equal to, when I create my new inequality to solve, I use or equal to. If my original inequality is not or equal to, when I create my new ones that I'm going to solve, I'm also not or equal to. Going back to the solving process, I'm going to add 4. I'm solving each of these individually because it's an or situation. So I get 2x is less than 0. I divide by 2. I know that it's okay to have 0 on top, so I get x is less than 0. Or, doing the same thing over here, I start by adding 4. 2x is greater than 8, and dividing by 2, I get x is greater than 4. So x is less than 0, or x is greater than 4. What does that graph look like? Well, here's 0, here's 4. I use an open circle, anything down here, or open circle, anything up here. Anything from either of those two regions would make this inequality a true statement. So say, for example, I plug negative 5 into this. Whatever this reduced down to would be greater than 7. If I pick something like 18, when I reduce that down, whatever I'm left with would be greater than 7. If I pick something from my non-shaded region, say like 2, and I plug it in here, whatever this reduces down to would not be greater than 7. It would be less than 7 because these values here are not part of my solution set. So I said that we would talk about this in the last video, so here it is. So again, absolute value bars sometimes make us think logically. Sometimes they break rules. So I give you a set of rules, a set of steps to follow, but we still have to make sure and think about each problem because sometimes those rules don't work. So I would set this up, correct? But isn't this telling me that this 4x minus 7 is a distance of less than negative 10 from 0? Does it make sense that my distance is going to be less than a negative number? Doesn't my distance, either I stay in the same spot and my distance is 0, or I move and my distance is more than 0. My distance that I go is never negative. You never say, oh, my friend and I went for a walk down the road, we went negative 2 miles. Does not make sense. So distance being less than a negative doesn't make sense. So this, I don't have to do any solving work. I right away say there is no solution to this. Again, think about with the solving absolute value equations. You have to have the absolute value symbols by themselves first. Okay, so make sure that they're alone before you make any kind of calls like that. Also in this other example, notice what this is telling me. This is telling me that this negative 2x minus 8, whatever that is, its distance is more than negative 4. Isn't your distance, again, always going to be bigger than a negative number because your distance either has to be 0, you don't move, or you move and your distance is bigger than 0. So no matter what I plug in there, it's always going to be bigger than a negative number because my distance is always going to be more than 0. Or as sometimes people end up saying, well, absolute value bars make everything positive, right? So negative 2x minus 8, a positive number has to be bigger than negative 4. So here is the situation where I can either say infinitely many solutions or all real numbers. I tend to say all real numbers are solutions. And if you were asked to graph that, all I would do is make my number line. I don't care what numbers you go to, but you shade the whole thing. All real numbers, everything works, infinitely many, however you want to think about it. In the same respect, if I were to graph no solution, here's my number line. I'm not going to shade anything, although I did draw my number line a little bit dark, but I'm not shading anything on that. So those are my two kind of funky scenarios.